So you want to get into IT, but you don't even know what a router is? Well, you got a problem. Hey guys, welcome back to Tech Logic Lounge. My name is Keith. Welcome to the channel where we help people get into IT by breaking down complex IT concepts. Make sure you like, comment, share, and subscribe. Let me know what you think about this video. But anyways, let's go ahead and get into it. So what is a router? We're going to go ahead and break this thing down as Barney style as we possibly can. So a router is a networking device that operates at layer 3 of the OSI model. If you don't know what the OSI model is, don't worry, I'm going to break it down in another video. But essentially, it's like a traffic cop. It takes the data that it receives from all the devices on its network that it's attached to and looks at its routing table, looks at the source address, so basically your laptop's address, which is an IP address. If you don't know what an IP address is, I'll break that down in a second. But it looks at the source address and the destination address, so where it's trying to go. So essentially, your laptop trying to get to google.com. It references its routing table, which is essentially a table that has a whole bunch of IP addresses in it, and it tells it which way it needs to go. And from there, it sends it out so that your traffic can get to google.com or wherever you need to go to. Now, before we get into further details on what a router is, let's kind of give a quick intro to what IP addresses are. So IP addresses are unique numbers, just like a phone number or home address, that are assigned to networking devices like a computer, your Echo, your Alexa. I hope I didn't make those go off just now, or your laptop or anything else. And essentially, that's what those networking devices use when they need to communicate with each other, or if they need to get out to the internet and reach some sort of external address. Now, IP addresses come in two different flavors, IPv4 and IPv6. And you can see the two different examples of those here and here. And essentially, those are the different types of networking addresses that could be used for devices. We're primarily still using IPv4. However, IPv6 is also coming into play more and more. Now, I'm not going to go into too much details about IPv6 now because that could be several videos. However, IPv4 is the primary address you're probably going to be dealing with for now. And that's a 32-bit value, which is broken up into 4 different octets. An octet is essentially the numbers that are in between each of these periods that you can see, and those values range from 0 to 254. Now, IPv4 addresses also come in two different flavors, public and private. Public addresses are going to be ones that can actually be reached from the internet, like Facebook and Amazon, and private are going to be ones that can be used for many different organizations. Those ones hide behind their organization's routers, and you can't actually get to them. Those ones are non-routable. IP addresses are going to be unique to the device, so not any two devices are going to have the same IP address if they're on the same network. And that's how the router knows who it needs to send traffic to. So if I have a laptop and its IP address is 192.168.0.1, when I send my traffic, I'm going to use that IP address and I'm going to send it up to the router. And the router knows if it receives traffic that's destined for that IP, it's going to send it back to my laptop. If your laptop has 192.168.0.2, the router is going to know to send any traffic destined for that IP address to you and only you. It won't send it to me because we have unique IP addresses. But anyways, that's enough about IP addresses. Let's go ahead and get back into, now, how does the router even know what your IP address is? Well, basically, for the most part, when your device actually connects to the network, it's going to do two things. If you have your computer signed for a static address, which is specifically you're saying you want this address, when it connects in, your computer is going to do an ARP, essentially an address resolution protocol message. And it's going to say, hey, this is my MAC address. My MAC address, if you don't know what that is, make sure you check out my previous video. But it's going to say my MAC address correlates to this IP address. And your laptop is going to go ahead and ensure that it keeps that in its ARP table and only send traffic for your IP address to that hardware device, that MAC address. Or if your computer's using DHCP, Dynamic Host Control Protocol, essentially it's going to reach out as soon as it connects in saying, hey, I need a server that can actually provide me with an IP address. Your router is going to see that broadcast and it's going to go ahead and respond to your computer saying, hey, here's an available IP address. You can go ahead and take this one. And it's also going to keep that in its ARP table so that it knows if it receives traffic for that IP address, it's only going to send it to that device. Now, I did mention broadcast a second ago, and there's going to be one important note that you're going to want to know is that routers actually break up broadcast domains. So when that computer comes online and it does a broadcast sends traffic to every single device that's connected on that network, and that can cause a lot of network congestion. Now, routers actually break up those broadcasts. So if that router is connected to several different networks, which generally is the case, it's not going to forward that broadcast to every different network. It's only going to keep it consolidated to that one network. Now, you also probably know that we use VLANs to segment out and break out our broadcast domains as much as we can. And routers are going to be the termination point. They're not going to let that broadcast go anywhere else. All right, so let's go ahead and give a visual representation of what that actually looks like. So let's say, not even fucking recording. All right, so let's give a visual representation of what that kind of looks like. So let's say we both have a PC and we're both connected to the same network. So I'm PC1 and you're PC2. And both of us connect up to the same switch and we're on the same VLAN in this case. And that switch connects up to a router and that router connects up to an ISP, an internet service provider like Bright House or AT&T Spectrum. So ISP, router 1, and switch 1. So when I connect to the network, I'm using DHCP. So I'm going to send out a broadcast to everybody on the network saying, hey, I'm looking for a DHCP server to provide me with an IP address. In this case, the router actually does do that. So I'm going to send the broadcast out. It's going to you. You're just going to ignore it because you don't do DHCP. And then you're going to send it up to the router. I'm going to send it up to the router, and the router is going to provide me with an address. In this case, 1.1.1.1. So now when I need to get anywhere, I'm going to use that IP address to get around. And the router is actually going to put my IP address in its ARP table, address resolution protocol, which is saying this MAC address is associated with this IP address. So my physical MAC address, which if you don't know what that is, check out my previous video, is tied to this IP address. Now you are assigned a static IP address that you've manually assigned yourself. So when you connect, you're going to send out an ARP message to the entire network, essentially saying, hey, my MAC address, my physical MAC address is tied to this IP address, and it's actually going to go to me as well. And then it's going to go up to the router, and it's going to say, hey, my IP is 1.1.1.2. And when you need to get around, you're going to do the same thing. And the router is going to put that address and MAC assignment in its ARP table as well. So now let's see how traffic actually works. So when I need to get somewhere, let's say google.com, I'm going to send out a DNS request asking what the IP address of google.com is. If you don't know what that is, don't worry about it right now. But basically, I just need to know what the IP address of google.com is. The router is going to go ahead and probably send the same thing up to another DNS server, and it's going to respond with saying, hey, google.com is 8.8.8.8, and that'll send it back down to my computer. Now, when my computer needs to go to google.com, it's going to send it up to 8. It's going to say, hey, I need to get to 8.8.8.8. So it's going to send it up to the router, and the router is going to look at its routing table, which is essentially a table filled with IP network addresses. And it's saying, hey, if I need to get to this network, I'll go to this router. Hey, if I need to get to this network, I'll go to this router. Hey, if I don't know where I need it, hey, if I don't have an actual route, I'm going to go ahead and just send it to this default route, which in this case is going to be the ISP. So router 1 doesn't actually know how to get to 8.8.8.8. So it's going to go ahead and send the traffic up to its ISP. And each router in between there is going to do the same thing until it gets to google.com. Eventually, google.com will go ahead and send a response back, and the router will send it down to me, and I will have my traffic. Now, let's say you're going to do the same thing. You're dirty. You're trying to get to feetfinder.com. You're going to go ahead and send out a DNS message asking what the IP address of feetfinder.com is. R1, router 1 is not going to know about it, so it's going to send a request and eventually get the actual IP address. Let's just say in this case it's 3.3.3.3. Now, when you go there, you're going to say, hey, my destination, my source IP address is this, and the destination I'm trying to get to is this. And you'll send that up to the router. The router doesn't know how to get there, so it's going to send it up to the ISP. The ISP may or may not know how to get there, and it's going to send it to the next router, and every router in between that is going to do the same thing until you get your dirty pictures, which are then sent back to the router, and the router sends all the way down to you, you filthy animal. And that's basically how the traffic flows in and out of the network using IP addresses. What does a router even look like, though? So routers come in many different brands, shapes, sizes, port counts, and a lot of different other options as well. And you're probably seeing a few examples go across the screen now. If not, you're probably looking at my awkward face, which is a little weird. But I also have some examples as well here. So I have this old AT&T DSL router, which not even used anymore. It's got a few ports on the back here and one port specifically for the DSL connection. And I've also got Big Bertha, which you can check this out here. So this is an ISR 2921. It's pretty big, but it provides all kinds of different services like voice services as well for managing actual VoIP phones, voice over IP phones, and there's many other options like this as well. But those are just a few examples, and you'll probably run into a whole many different kinds going throughout your IT career. All right, bastards. So if you're feeling ballsy, we're going to go ahead and jump into a lab here that I have set up in Packet Tracer. If you don't know what Packet Tracer is, it's basically a simulator that you can set up and you can manage virtual switches and routers and practice setting them up so you can actually study for your CCNA or even real world examples as well. So we're going to go ahead and jump into my lab. I set up a basic config and we can see that and see how router actually works. So let's go ahead and get into it. All right, so this is Packet Tracer, and the cool thing about it is you can set up actual labs and even pull labs from online that people have already pre-configured, and sometimes they even leave stuff in there for you to troubleshoot. But this example here, we're going to go ahead and open up a pre-saved lab I have, which is pretty cool because all you got to do is go here. If you have something saved, you can go ahead and save it. So here's my lab here, intro to routers, and just open it up. And you can see I've got two PCs with a switch and a router with another router connected to a server. And just to give you a quick breakdown, so this switch here has two different VLANs on it, VLAN 10 and 20. The network address is 192.168.1.0 for VLAN 10 and 10.0.0.0 for VLAN 20. Those both connect up to a 2911 ISR router. And we're actually going to go ahead and configure these sub interfaces for this router so that it can route the traffic from these VLANs out. Specifically, these routers are going to want to go ahead and reach this secondary router and then over to this web server here, which actually has a web page that we're going to try and reach. So let's go ahead and start with the switch first and just check out what it looks like. All right, so if we jump into the switch here, you can see that it does indeed have those VLANs, VLAN 10 and 20. 10 for the feet fetish guys and 20 for the ear fetish guys. And 10 should be connected to fast Ethernet 1 and 20 to fast Ethernet 2. And if we look over here, that indeed is the case. 10 is going to 1 and 20 is going to 2. And just bring this out a little so it's a little bit easier to see. And then we can also see that we have a trunk which passes all the VLANs up to the switch itself on fast Ethernet 3. So if you look at fast Ethernet 3, you can see that we do indeed have a trunk, and it is on fast Ethernet 3, and it's passing VLANs 1, 10, and 20, which are the VLANs that we need to push up there. So now we're going to go ahead and jump into the ASR and see what that looks like. Alrighty, so we're going to do a show IP interface brief and see if there's anything on this router right now. We do have one interface, and it's 10.1.12.1, which is connected between router 1 and 2. The 12 on the third octet represents router 1 and 2's numbers, and the fourth octet will represent the router number. So .1 for router 1 and .2 for router 2. But we still need those sub interfaces for each of the VLANs so that those so that those PCs can actually get out of the network and over to the web server. So let's go ahead and set those up. So we're going to go into configuration mode. And from here, we're going to go ahead and go into interface gig 0/0. But in this case, since we want to go ahead and set up a sub interface because we're going to be using a router on a stick method, if you're not sure what that is, don't worry, I'll bring that down in another video. But we're going to go ahead and set up a sub interface for VLAN 10 first. So we'll go into gig interface 0.0.10. We'll go ahead and do a no shut on that. No shut. And then we'll give it an IP address within this gateway or within this network. So this router is actually configured with a gateway already. And we see that its default gateway is 192.168.1.1. So we're going to go ahead and give the router that gateway so that it's pointed to the right network address. So IP address 192.168.1.1. And we're going to give it a /24. Oh, got to do encapsulation.1q first. So encapsulation.1q10, which is just saying that it's going to be processing packets that are tagged with VLAN 10 on it. And then we'll go ahead and give that IP address. Let's see here. Expand that so I can see a little bit better. So 255.255, there we go. And then now we're going to go ahead and go into interface VLAN, interface gig 0. And then we're going to do .20 to represent our VLAN 20. And from there, you're going to double check this default gateway to see what it's configured with. And we can see it's configured with a default gateway that's 10.0.0.1. So that's where we're going to go ahead and give the router so that it's pointed to the right default gateway. So we'll go ahead and do an encapsulation .1q20 to say that it's going to be processing packets for VLAN 20, and then give it an IP address of 10.0.0.1, and it'll be a /24, so 255.255.255.0. And if all these numbers are just kind of mumbo jumbo to you, don't worry, I'll break that down in another video as well. And then we're going to no shut this port so that it comes up. And from here, this router should now be able to ping down to these two interfaces, or these two devices, assuming they're configured correctly. So let's see. So do ping 10.0.0.2. Nope, looks like we're good. We missed the packet at first because we had to go ahead and do that ARP. Since these devices aren't just coming up, they've probably already missed the ARP. Or the router's probably already missed the ARP. And then we'll go ahead and check the other laptop as well, which is 168.1.2. And it looks like it's good. And if we go ahead and actually look at these laptops and this PC, we'll see that they are actually configured with 192.168.1.2 and 10.0.0.2. So we're good to go. We pinged both devices, so they should be able to get out now. Let's see. Oh. Go ahead and ping up to the device itself. Cool. And ping 192.168.1.2 or 1. Yes, it can reach the router as well. So we're getting the traffic all the way from the devices themselves through the switch up to the router. Now we need to make sure that the router over here can ping this router. Let's see. And we will grab this router as well, and we'll put it over here. Get into the CLI of it. We'll do a show IP interface brief. And we can see that this router itself does have an IP on the same network as the other router, or the router that's connecting the two here. Go back to that and see that here. They're both on that 10.1.12.0 network. This is .1, this is .2. And now, can they ping each other? So ping 10.1.12.2. Yep, it can ping, and ping 10.1.12.1, and it can ping as well. Now this also has an IP address on the network that's connecting us to that web server, and it should be able to ping at that web server is configured with the IP address of 172.161.2. So we'll go ahead and do a ping 172.168.1.2, and it can indeed reach it. And if we actually go to that server itself, we should be able to actually see that server's IP address as well. So we'll go to config, and we can see that it is configured with a default gateway of 172.161.1, and its IP address is 172.161.2. Cool. So now let's go ahead and look at the routing table. So remember before we said that routers do have a network table that they reference when they need to send traffic. So we need to see if these routers can actually see the networks that are sitting behind them. So in this case, we want to be able to see if this router here, router 2, has routes to be able to get to the 192.168.1 network and the 10.0.0.0 network. Let's see if it does. So we'll do a show IP route. It does not look like it has a route in there for any of those networks. So what we're going to do is just create a static route in this case. And we'll do IP route 192.168.1.0, 255.2.0, and then it's going to be 10.1.12.1. So we're basically saying that if the router wants to be able to get to this network, it has to go here next, which is this router's IP address. Now we're going to do the same thing for the other network that router 1 is hosting, which is IP route 10.0.0.0, 255.255.0, and it's going to also be pointed to 10.1.12.1. Now we need to go to router 1 and see if it has a route to be able to get to the 172 network, which is where that web server is at. So let's do a show IP route. So we're looking at the routing table, and we do not see a route for the 172 network. So we're going to go ahead and create a static route. IP route 172.168.1.0, 255.255.0, and that's going to be pointed at 10.1.12.2. Now if we do show IP route, which we're looking at the routing table again, we can actually see that we do have a route in here now for this network, and we're pointing it at 10.1.12.2, which is router 2. And if we look at router 2's routing table now, we should see networks for router 1's networks, which are here. Yep, we got the 10.0.0.0 network and the 192.168 network in there. And now let's see if they can actually reach those networks. So can router 1, in this case, so can router 1 reach the server over here, which should have an address of 172.161.2. So ping 172.168.1.2, and it indeed can. Now can this router here ping this network over here, specifically both of them? Let's see. So this is going to be 192.168.1.2 and 10.0.0.2. So let's see. So we're back on router 2, and we'll go ahead and ping 10.0.0.2. Can reach it, and ping 192.168.1.2, and it can reach that as well. So now that we have routing being able to get all the way from over here to over here, and from over here to over here, let's see if we can actually pull up the web page that this server is hosting. All right, so we're going to go ahead and open up that laptop and open up a web browser and give that a second to load. And from here, we're going to go ahead and try and hit this server's IP address, which if you go to config, we'll just confirm it is 172.161.2. So that's what we're going to go ahead and try and hit. We bring back up that laptop's web browser, and we will go to 172.168.1.2. Bam, look at that. We're hitting the Feet Finder website. I know some of you guys are liking that. You can check this out later on if you want to. So that's how a router gets its traffic all the way from that dirty laptop you got across the internet. All right, so that's it. That's a little bit about routers. We know they function at layer 3 of the network. They worry about those packets and IP addresses. They go ahead and reference their ARP table to send packets that are related to your IP address down to your specific hardware, like your laptop, your IoT, Internet of Things devices, your Amazon Echo, or anything else. Routers reference the routing table, which is a table filled with a whole bunch of network addresses, and tells the router which hop or which router it should take next to get to that network address. There's a default route which says, hey, if I don't have a specific route for that network, I'm going to go ahead and just send it here. And we now see how that router actually gets that packet all the way to the server. But that's it. I hope you guys enjoyed the video. If the audio's off, don't worry. I'm going to fix that in the next video. I don't know what happened. But anyways, make sure you like, comment, share, and subscribe. Drop a comment down below letting me know what you guys want to hear about next. I appreciate your time. You guys take it easy. Peace.